Good morning, welcome to the next session. Today I am going to talk about creating a development infrastructure for our data science project, and in general I am going to talk about implementing model OPS, that is model operations. So this is very important chapter and it deals with the testing of the model and it also deals with the development of the infrastructure. So let us look at the objective. So the objective is very simple. Model OPS and its close cousin called Dev OPS, development operations or model operations. We'll explore how to build a development pipeline for our DS project and make the project reliable, experiment reproducible and deployable fast. So we have three things to worry about. Number one is make the project reliable. That means the project which we are developing has to be reproducing, or last time also I have shown you the project should be reproducible. That means the same code should give the similar output next time too. Then it should be deployed very fast. Now how do we do it? Very simple. To do this, we will familiarize ourselves with the general model training pipeline and see how data science project differ from our ordinary what we call as a software project from the development infrastructure perspective. We will also see what tools can be help to version control, track experiment and automate testing and managing the Python environment. So most of the data science projects are using Python as a built-in environment. So I'll show you how to use the Python environment also. So using these tools, we'll be able to create a complete model operations or model op pipeline, which will automate the delivery of new model version, taking care of the reproducibility and code quality. So we'll consider or we'll cover this following topic. Number one, understanding and looking into the model operations or model OPS in short, it is very popular. Next point is managing code versions. So when we are developing the code, tomorrow I enhance my code, so version has to be enhanced. So managing the code version and the quality of the code. Storing data along with the code, very important, and then managing the entire environment. Tracking experiment, importance of automated testing and continuous model training and a power pack for our project. So these are the topics which we are going to cover. So let us see what is model OPS. Model OPS is a set of practices for automating a common set of operations that arise in the data science project, which include the following. So model OPS is nothing but a common set of a data operations, and these operations include training, model training, data management, version control, experiment tracking, testing and deployment. So if you look at the 6 point, very simple, is a pipeline. That means from the training of model, we will go to the version control, then we do the experiment, we test the experiment and then finally we deploy it. So this is what we call as a complete pipeline. I have just shown you a diagram here. So without model OPS, teams are forced to waste time on those repetitive tasks. So many of the tasks which are here are repetitive, and each task in itself is fairly easy to handle, but a project can suffer from mistake in those steps. So how do model operation pipeline help us? Model OPS help us to create project delivery pipeline that will work like a precise conveyor belt with automated testing procedures, so that they will try to have the less and less number of coding errors. So we'll be able to catch the coding errors very quickly. So with this intuition, let us see what a Dev OPS or model OPS is all about. So Dev OPS stands for development operations. So I have a model OPS, model is complete one, and I have a development operation. So a cousin of model OPS is Dev OPS. So Dev OPS stands for development operations, and software development process include many repetitive and error prone tasks that should be performed each time the software makes a journey from what? Source code to the working product. So when I am developing a software project or a software product, starting from my development of the code to the final stage, I am likely to commit so many number of mistakes which are repetitive in nature. So let us do a examination. So, examining a set of activities that comprise the software development in a pipeline are performing checks for errors, typo errors or typos, bad coding habits and formatting mistakes. So, very simple and very crucial is your checking for the error, typo error, bad coding habits we always have, and performing sometime instead of putting a double angle bracket we put another kind of a bracket. Okay, there we have all kinds of coding habits because of various languages we know. Second point is building the code for one or several target platforms. Many applications should work on different operating systems. So, this is a very important point. Point number 2, whatever code I have written, it has to work on different operating system. For example, it has to work on Windows, it has to work on Linux, it has to work on any other operating system too. Third point, running a set of tests that will check the code work as intended and according to my requirement, and finally pick the code and deploy the code. So, with this development environment, let us see what is meaning by CI/CD. Continuous integration and continuous deployment. Very simple idea. I have a continuous development occurring. So, I will have a continuous integration, and once the job of integrating the software code is over, I have to go for a deployment. So, CI/CD state that all the steps can be and should be automated and run frequently as much as possible. So, smaller updates are thoroughly tested for more reliable, and everything goes wrong, it is much easier to revert such an update. So, if something goes wrong, it is easier for us to find out the mistake, it is easier for us to go back and see where we went wrong. Before CI/CD, the throughput of the software engineering who manually executed the software delivery pipeline was limited to the deployment life cycle only. So, it was a hindrance, it was a big problem. So, what is the answer? We say now highly customized CI/CD services, okay, get rid of the manual labor which was there and completely automate all the necessary activities. They run on the top of the source code version control system and monitor for new code changes. So, even if I change my code, the system is going to track me the changes of the code too. So, once a new code change is present, a CI/CD server can launch the delivery pipeline. To implement DevOps, you need to spend time writing automated test tool and defining software pipeline, but after that the pipeline just work like every time we do it. So, DevOps take the software deployment system world by storm, producing many technologies that software engineering maybe have been productive. So, like any other technology ecosystem, an expert need to have to devote time to learn and integrate all the tools which are necessary for DevOps. Over period of time, CI/CD servers became more sophisticated and feature rich. Feature means they already have so many number of features built in. So, we can take the advantage of those feature rich properties. And subsequently, many companies felt that they need to have a full-time expert capable of managing and delivering pipeline of their project, and that is the role of my DevOps engineer. Many tools from the DevOps world are becoming much more easier to use, requiring only a few couple of clicks to interface them. Some CI/CD solutions such as GitHub add us to create a simple CI/CD pipeline. So, with this idea, we can create a JIT hub and create a CI/CD pipeline. Now, let us look at some of the property of the project and how the JIT works, and I hope many of us are familiar with the JIT hub too. If not, it's very simple. You can go and visit the JIT hub website and can see the details about this. So, let us see one by one. A modern software project will likely to use the following infrastructure to implement a CI/CD. Number 1, version control. So, when my project code get updated, I have to have a version control 1.1, 1.2, 1.3 or 2.1 and so like things like that. Code collaboration platform, when different people are collaborating a different code, you have a code collaboration platform, automated testing framework depending upon the implementation language, and finally I have a CI/CD server which is a Jenkins server, or a Travis CI circle, or a Circle CI circle, or a CI Circle CI, or a JIT Lab CI. So with this, you can see the 4 points gives all the infrastructures which are needed for a DS project implementation infrastructure. So all of these technologies miss several core features that are critical for a data science project, like data management tools for solving the issue of the version control, for automated test file, experiment tracking, automated testing, and all. So we'll incorporate all these features in our data science project too. So let us see what a delivery pipeline of a data science project. A DS project consists of multiple data processing elements. So you can see I have a I have a raw data. From the raw data, I have a pipeline called as exploratory data analysis. Okay, I give the report, data processing file pipeline, process the data, then it comes to the model. So I have a model data set pipeline, and then model test the model on a different data set. So I have model data set testing, then I have a quality control, and then training and finally a trained model. So starting from my raw data, this is the pipeline going through. Okay, so you can see that each stage, each model pipeline starts with the raw data, which is stored in some kind of my data source, which is shown here. Second point is then data scientists perform EDA, that is exploratory data analysis, and create a EDA reports to deepen the understanding of the data set and discover the possible issues with the data. So with this, you can see here the model dataset pipeline create a ready to use dataset for training and testing model, and the model training pipeline uses a prepared dataset here, okay, and to train the model and assess their quality of performing offline testing and generate a model quality report that contain detailed information about the model testing result. So with this pipeline, it becomes very easy. So at the end of the pipeline, you get a final artifact, which is nothing but a trained model here, okay, which is saved on the hard disk or on a database. So with this, we can manage the code. So how to manage the, with this we can develop the DevOps and MLOps pipeline. Now, how do I manage the code version? Code versions are simple, and DS project deal with a lot of codes. So data scientist needs to use the version source version control. So we use the SVC, source version control system, such as JIT as a mandatory component. So the most obvious way of using our JIT is to employ a code collaboration platform such as a JIT Lab or JIT Hub. Those platforms provide ready to use JIT server along with the useful collaboration tool for a revision or a code review and issue management, okay, and making working on a shared project easier. Such platforms also offer integration with other CI/CD solutions, creating a complete and easily configurable software deliverable pipeline. So you can see that JIT Lab and JIT Hub are always free, and they are very good for developing the code version and quality of the code. And many teams synonymize JIT with the one of the popular platform offering, but sometimes it is useful to know that is not only the option, we have other options also, okay, but this is the most popular one, we use it, okay. So you can see here I have just shown you the code from the book. So JIT clone and -- where project location, my code, remote location, and I put a copy. So you can just see we have push request and pull request, okay, request available on this. So if you just go through the code, it's very easy to understand, and you can see that by changing the path from a triple hash to a secure shell double path, you can change the remote location of your network to network, and you can have a host machine on your local network too, okay. So with this code, very easy for us to manage the code. So most data scientist projects are written using Python, where static code analysis and code build systems are not widespread in use in the other programming languages. Those tools allow us to groom code automatically and change the critical errors and possible bugs in a timely manner. So you have a Python, and Python have a pre-commit. So you can go to the website called as precommit.com, and you can see the Python voila. Okay, so following screenshot demonstrate the running of a pre-committed Python code. So you can see that if I go to this website and see all the files, you can go and it is showing you initializing the environment, building the environment. It will take few milliseconds, and it will go on checking one by one, okay, and finally fixing the bug, Okay. So, having this is a recommended system, and it tells you also very important thing about pass and fail. That means this up to this unit has been passed, and up to here this has been failed. So, you know which is giving you a problem and which is not giving you a problem. So, with this we can store the data, and you can see here those units which have passed are shown by the green color, and those who have failed are shown by the red as a background. So, we know where is the problem, and we can make our all the efforts on the failed code or failed segment area, and so that we can more and more give emphasis on the failed code area. So, storing data along with the code. So, we can store the data along with the code on the JIT Hub too, okay, and data version control is available on the JIT Hub too, and we can track the code and version on the data. So, such a pipeline is very useful for tracking the data and version control too. And after controlling everything as a pipeline structure, we can have an intermediate result as an interesting topic that will describe the what we call as a special attention. So, I can go on seeing the intermediate result, and I will be able to see where my results are not matching, where results are matching, then I will be able to develop the code much better. Okay. So, be aware that model training pipeline and production pipeline should be different. A model training pipeline might have a lot of intermediate steps for resource flexibility, but a production pipeline should be highly optimized. So, this is the underlying principle. Model pipeline is different and production pipeline is different. Production pipeline has to be highly optimized for performance and reliability. Only intermediate steps that are strictly necessary to execute the final production line should be executed. So, storing data file is necessary for reproducing the result, but it is not sufficient for understanding them. So, we can save ourselves a lot of time by documenting the data description along with the report that contains summaries and conclusions that our team draws from the data itself. So, if you can store all this document in a simple text file, we can have a easily tracking of the system. Okay. So, you can use the following folder information. For example, I make a project, under that I may create a subfolder called data. Under that I can create three more subfolder: raw data or interim data and pre-processed data. So, that under the project root I have a data, and I know where I am working and where is the chances of my committing the error, and at which stage my modification need to be done. Next point is report, project report for EDA, model quality and so on, and finally the references, data dictionary and data source documentation. So, such a beautiful way we can track the changes in our project, and we can really make our data science project life very easy. So, storing my data, you can store the data on our JIT Hub server, and we have explored importance of the data and management data artifact along with the code. Okay. So, you can see that you can store the data on the JIT Hub also. Okay. So, here it is showing you all the details above. Okay. And yeah, so you can see here I am showing you all the BSD, Berkeley Software Distribution 3 class. Okay, that is our Linux and Unix based operating system, and it's showing you a BSD 3.3 class. Import number from warning, import catch warning, simplify warning, and import trading, and this giving you maximum input. So, you can see all the definition and go the number of cell and put parameter. So, you can see that all these things are available under the storage practices, and we use a beautiful command called as diff. If you remember, diff is a beautiful command for Linux operating system, which tells the difference between any two files. So, if I want to change, if I want to check the older version and the newer version, I can use the diff command. So, you can see here the highlighted line with marked with the plus sign added lines. So, these are the lines are added in my system, and those lines which are shown by a minus sign are being deleted line. So, here it becomes very easy to track the changes in the code. Okay, and diff command is a command in the Linux operating system. It gives me all the output as a difference between the two files. Okay, so diff file server okay, use a very specific problem. They allow developers to browse, discuss and see and switch between the set of changes. Diff is a line based command from the operating system, very popular under Unix operating system. So I hope I have covered about the all the pipeline and using the diff command. So with this GIT hub and pipeline and diff command will be able to generate a good model OPS development pipeline. Thank you.